Hello and welcome back. In a previous video, we looked at how to create visualizations of single variables. Those are univariate plots. But of course, most visualizations are looking at the relationships between multiple variables. In this lesson, we're going to see how to do this. So let's get started. So as usual, we start by opening up a new Google Colab notebook, or you can open up a notebook in whatever environment you use. And this one I'm going to call multivariate plots, or you could say multivariate visualizations. And I'm going to click on the top right button here to toggle the header visibility, so I have a bit more space. I've also pasted our list of learning objectives. If you like, you can pause the video and read through these, but we're going to come back to them at the end of the lesson. Let's begin by importing some key libraries. I'm going to open a new text chunk here, and I will call it imports. Imports, not all capitalized. And then I will open a new code chunk underneath that, and I'm going to import the following. Plotly Express, okay, hopefully you remember that one, as px. We're going to import pandas as pd. Remember, pandas is for data frame manipulation. We'll also use the numpy library, sometimes called numpy, and p. And we're going to use the Vega datasets library as well. So from Vega datasets, we import data. So press Command Enter or Control Enter to import all those libraries. And this chart here is the framework around which we are going to structure the lesson. So if you need a refresher of what this chart shows, it shows a brief flowchart of some different visualization styles we can use for different kinds of visualizations. If you have a single variable and it's numeric, the chart recommends that you can use a histogram or a violin plot or a box plot or a jitter plot, which show very similar things. If you have a single categorical variable, a bar chart or pie chart is good. But if you have two variables, which is our focus for this lesson, and you have a numeric versus numeric dataset, or numeric versus numeric pair of variables, then of course a scatter plot is very good for that. And that's what we're going to start with. So we're going to look at how to plot numeric versus numeric data with scatter plots. So let's go back to our Google Colab notebook now, and let's make a new text section and call it numeric versus numeric data. And in a subsection, we can say scatter plot. For most of our practice, we are again going to use the tips dataset, which comes from Plotly Express. So in order to extract that, let's type tips equals px, which stands for Plotly Express, and then the data module of that. And within there, we can extract the tips sample dataset using this. And let's print it to the next line and press Control Enter. And so for those that need a refresher, each row here represents a specific customer that gave a waiter a tip. So this is a waiter in the US that recorded all the tips that they received and also the characteristics of the person who gave them that tip. And so we may be interested in visualizing the relationship between the total bill that the person paid and how much they tipped. And we can do this with a scatter plot. So let's clear this output and let's open a new code cell and type px.scatter. That is the scatter function. And we put the name of our dataset. And then we're going to put the variable on our x-axis, which in our case is going to be the total bill. And then on our y-axis is going to be the tip amount. And if we press Control Enter, voila, we should have our very first scatter plot. And very nicely, as you can see, Plotly allows us to hover over each point and see the exact total bill and the exact tip amount. Now let's customize the plot a little bit by changing these x-axis and y-axis labels and also adding a title. So let me clear this output, and then on a new code cell, I paste the code, and let's add some additional arguments. I put a comma, and I'm going to add the labels argument. And labels accepts a dictionary, as you see there. And we're going to put the name of the variable first. So total bill as the key. And then the value is going to be what we want to replace it with. So in this case, I'm going to put something nice like total and a space bill. And then I put the US dollar sign. Or maybe I just type USD. And then for the second label, I'm going to put another key value pair inside of this dictionary. And I'll put tip amount, maybe tip amount, again in USD. And finally, let's add a title. Title equals relationship between total bill, and tip amount. So now we run that and make sure that everything seems to be good. Amazing. So now here is some practice for you. I want you to use the Gapminder dataset, which I'm going to show you how to get in a second. Okay, specifically the 2007 subset, and create a scatter plot showing the relationship, let me go to a new line, relationship between GDP per capita and life expectancy. And the Gapminder dataset again comes from the Plotly library or Plotly Express. So we type px.data.gapminder, and then I'm going to subset to just 2007. I'll call that G 2007. And I'm going to type some pandas code here, but you don't really need to understand what's happening. We'll teach you pandas later on. And let's view the head of that dataset. And so what we have is a dataset where each row is some information about a specific country in the year 2007, including their life expectancy, as you see here, and their GDP per capita. So make a scatter plot of this data. And when you're done with that, answer the question, what is the relationship between the two? So how would you describe the relationship? Going back to our framework here, we're now interested in looking at numeric versus categorical plots, and we're going to look at grouped histograms, grouped violin and box and jitter plots, and then we're going to look at bar charts with summary statistics. So I open a new text section and I call it numeric versus categorical data. And in a subsection, I'm going to start with grouped histograms. And I'll start by reminding you how to make a histogram of a single variable. So if I wanted to make a histogram of just the values of the tips, I'll do px.histogram. I put in my tips dataset, and on my x-axis, I'm going to put the tip column. So here is how you do a single variable histogram. And now if we want to create a grouped histogram, all we have to do is add a color axis. So in addition to x equals tip, I'm going to add color equals sex, because we want to compare the tip amounts from men and women. Take a minute if you like to pause the video and try to understand what this histogram shows. This is a stacked histogram. And so what it's showing is that in between, say, 1.75 and 2.24, as you see this bar is, there were 38 men who gave that amount of a tip, and 17 women. Instead of stacking the histograms like this, we could also overlay them on top of each other with some transparency. So let me close this output and open a new one. And I'm going to copy this, and I'm going to put now bar mode, this help tab is a bit annoying, bar mode equals overlay. And if I run this now, what we're going to have is two overlaid histograms. So imagine you have two separate histograms, but they're both sort of transparent. So you can see the one that's behind the other. And the red one here is the one for men, and the blue one is the one for women. So now I want you to do some practice on creating a grouped histogram. I'm going to open a new code chunk, and I'm going to type practice. And what I want you to do now is use the LA riots dataset from Vega datasets, and create a grouped histogram, of age by gender. And then according to this plot, I want you to tell me, was the oldest victim male or female? I struggle to type because my screen is quite far from my keyboard. So sometimes it's a bit annoying. And let me show you where that dataset comes from. It's going to come from the Vega datasets package. And remember, we imported the data submodule of Vega datasets. So we're just going to pull out LA riots from there. So we say LA riots equals data.la riots. And let's view the head of that, LA riots.head. So here's that dataset. It's kind of a sad dataset. It's victims of the LA riots. So people who died in the LA riots. Maybe you remember that event. What I want you to do is just create a grouped histogram showing age by gender. So pause the video and try that out. Now, another kind of plot you can create in order to compare a numeric value across a number of different categories is this kind of plot, a grouped violin plot or a box plot or a jitter plot. Let's see how to create these. So we're going to make a new section now, a new text section, and call it a violin and box plots. And first thing I'll do is show you how to make a simple univariate violin plot. So for this, I'm going to type px.violin, and I'm going to visualize all the tips, all the tip amounts. So y equals tip. And if I run this, you can see this violin. What this is a kind of a density chart. So places where the violin is fat are places where a lot of people gave that amount. Here we put the tip on the y-axis, but we could also put it on the x-axis. It's completely up to you, but I'm going to leave it for now on the y-axis. And we can add a box to this violin by just adding a box argument. So I'm going to clear outputs, and let's put in a new code chunk, copy, paste. And I'm going to put box equals, it's hard to see what I'm typing, box equals true. And if you run this, now you have a box plot inside of the violin. If you want just a box plot, then you can also do the following. We can type px.box. So instead of violin, we just type box, and we do tips. And again, y equals to the tip variable. And this gives you just a box plot. And finally, if you want to add the points as well, as in the jitter plot, in addition to box equals true, you can add points equals all. So let me show you how to do that. Let's open a new code chunk, and then I'm going to add points equals all. And actually, maybe we don't need box equals true for this demo. So here we have the jitter plot beside the violin plot. So those are demos of how you create the univariate violin or box plot. Let's see how you can make now the multivariate one. It's really quite simple. Let's take one of these existing plots, maybe this violin plot with a box. Let's open a new code chunk, paste it in, and maybe let's call this now multivariate, since we've been doing a bunch of univariate ones. And in order to add another variable, I'm just going to add x equals sex. And now in addition to, whoops, I'm missing a comma there. In addition to the tip variable, now we also have the sex. So we're distinguishing the two distributions by sex. And so we've already distinguished them on the x-axis. We could also distinguish them by color. So we could add color as well equals to sex. And now maybe that looks a little bit better. Okay, so based on this, now I want you to do some practice. Let's open a new code section and call it practice. And I'm going to say, again, using the G2007 dataset created above, use a violin plot to compare the distribution of life expectancy by continent. And then according to the plot, which continent has the highest median? Which continent has the highest median life expectancy? So pause the video and try that out. So now we've talked about the grouped histograms and then the grouped violin/box plots. Let's see now how you can do a bar chart with summary statistics. Because a bar chart basically shows only one value per category, then you have to summarize all of these points or all of this density into a single value so that we can put it on a summary chart. And the value usually is going to be a mean or maybe a median. In our case, we're going to do a mean. So let's open up a new text section now and call it summary plots, and then let's do mean and standard deviation. Or maybe let's say summary bar charts. And I'm going to use some pandas code to summarize our specific data set. Again, we haven't taught you this at this point in the course, but just type what you see, and later on you'll learn how to do this. So I'm going to create a summary df using the tips dataset. Tips, first I group by the sex variable, so I can create a summary per sex, and then I'm going to create an aggregation. For our aggregation, we're going to create a variable called mean tip. That's the average tip. And we're going to define a tuple here, tip and mean. So it takes the tip variable and creates a mean of it. Then let's do standard deviation tip. And again, we have a tuple. And in this case, we're going to grab the std function. And finally, we reset the index. And let's print out the data frame to see what that looks like at the end. So now we have the mean tip for females and the standard deviation, and the mean tip for males as well as the standard deviation. So now let's see how we can plot this. I'm going to open a new code section, and I'm simply going to type px.bar. So this is how we're going to make this bar chart. And let's grab our summary df. And on our x-axis, we're going to have the sex variable. On the y-axis, we're going to plot the mean tip. Let's put that in quotes, mean tip. And finally, we're going to add an error y argument, error y, and set that equal to the std tip. Std tip. All right. And now if we run this, we should have our bar chart with the standard deviation error bar. Now, based on this, I want you to do some practice. And what you're going to do is create a bar chart of the mean total bill by day, okay, with standard deviation bars, with STD bars, okay? And just to be clear, how you should go about this is just copy and paste the above code and adjust the pattern, okay? Adjust the pattern. So hopefully you understand what I mean. You just grab this code, and then you're going to change the relevant things in order to switch from tip to the total bill, and in order to switch from sex to the day of the week. Of course, this is using the tips dataset. So let me make that clear. Using the tips dataset. Okay, so now we're going to go on a little bit of a detour and talk about the difference between the px.histogram function and the px.bar function, because that's a common source of confusion. So far, even when we are creating bar charts, we've been using the histogram function. But now, for the first time in this example above, we use the bar function. So what's the difference between histogram and bar, at least within Plotly Express? So let me show you the difference. So basically, the difference is that px.bar expects that you have pre-calculated whatever numeric variable you are trying to plot. And px.histogram, rather, will do the counting for you. So what do I mean by that? Let's start by doing something like this. px.histogram, and let's grab the sex variable on the x-axis. So px.histogram of tips, and then let's grab the sex variable, and let's plot that. So what has happened now? Let's first look at the sex variable above here so that we can easily see what we're doing. So remember that this is a tips data set. It has 244 rows, and the sex variable records women and men. And so all we did was we gave it this variable here, and it calculated the number of women and men in the data set. So we didn't pre-count this 87 and 157 that you see here when you hover, okay? The function did it for us. So that's what px.histogram does, is it counts the variable for you. But if you have already counted the variable or you've already pre-calculated some number, then you're going to use px.bar. So let me show you what I mean. I'm going to open up a new code chunk, and I'm going to actually use pandas to count the sex variable before passing it to a plotting function. So I'm going to type tips, and I'll subset to the sex variable. Now, again, this is code that you're not too familiar with, so don't try to understand it. And I'm going to grab the value counts, and let's reset that index. So what this does is it counts men and women, okay? And it gives us this count variable. So now we have a pre-calculated count, and now we can use the px.bar function. So let's store this in something called sex counts, and let's paste sex counts there and view it so we can easily see what we're doing. Now in a new line, I'm going to type px.bar. We're going to plot the sex counts data set and pause and think about maybe what we should do here. So for our x-axis, we're going to have x equals sex, and our y is going to be count. Okay. So now we have the same plot, although it's swapped, as here. So here we just give it the sex variable, and the histogram does the counting for us. Here you have to count first, and you have to give it both the x and the y variables in order for that to work. So that's the difference between the bar function and the histogram function in Plotly Express, and it will be useful to know as you keep going along. Okay, we're making good progress. Now we want to talk about categorical versus categorical plots. And basically for these, you're going to use bar charts that have a color axis that allow you to differentiate further categories. So let's start with a regular stacked bar chart. I'm going to open a new text section now and call it categorical versus categorical data. And under there, I'm going to open a stacked bar chart subsection. And again, for stacked bar charts, we're going to use the px.histogram function. And our goal here was to look at how the sex ratio differs by the day of the week. So we're going to do that here. Again, with our tips dataset, tips. And and on the x-axis, we're going to put the day. And for the color axis, we put the sex. And if we run this now, you can see that we have the count of men on Sunday above the count of women on Sunday. Same thing for Saturday, and so on and so forth. So a very easy way to compare that distribution. And let's add some modifications to this plot to make it look a little bit nicer. So I'm going to add a new code section, paste this, and let's add some extra things. So first of all, we can add the text_auto function, set that to true, and that will add counts to each of these sections. So that's pretty useful to have. In addition, let's use some nice colors. So I'm going to use the graph network colors that you saw on that chart. Let's use color discrete sequence. It's a bit of an annoying long argument, but that's what it is. And here are some colors that look similar to the graph network colors. DEB 221 and also 2F8, 2F8, 28A, 28A. And if we run this now, we should have a bit of a nicer looking histogram. Very beautiful. Let's hide this output and let's give you a practice section on that. So for this practice section, you're going to use the G2007 income dataset created below to build a stacked bar chart showing the count of high and low income countries per continent. Okay. And in order to create this data set, again, I'm going to write some pandas code. So first of all, let me just copy this code so I don't keep needing to write the same thing over and over. All right. So if you need to pause the video to catch up, that's okay. And I'm going to create a G2007 income, and I'm going to embrace all of these in a pair of parentheses. And now after that query, let's put the query on a new line so it's easy to read. And let's drop a number of columns, again, to make things easy to read. Columns equals, and we drop the following list of columns: year, ISO alpha, and also ISO num. Again, this is code that you don't have to know by now. And now I'm going to create a new variable with the assign function, and we call it income group. And in order to define that variable, I open up a lambda defined on df. And I use the mp.where function. Within mp.where, I'm going to grab now the GDP per capita. I grab the GDP per capita variable. And if it's over 15,000, I want to define that as a high income country, high income. And otherwise, I want to define it as a low and or middle income country. And finally, let's print the head of this data set, G2007 income.head. All right, so that was a lot of code, but what we have done now is we have this data set where each row again is a country, but we've added another categorical column, so you have another categorical column to plot. So what you're going to do is plot a categorical versus categorical stacked bar chart showing the count of high and low income countries, so count of this income group per continent. So pause the video and try to do that. Now for our final section, let's see how to make a percent stacked bar chart. This is really quite simple. Let's make a new text section and call it percent stacked bar chart. We're going to start with the regular bar chart that we had here, the regular stacked bar chart. And I'm just going to add another argument to it. That's how nice Plotly is. All we're going to do is we add bar norm. Well, first of all, let's plot this one just so you can remember what it looks like. So here, this is what that looks like. Now we add a bar norm argument, which stands for bar normalization. And let's click away to hide this help. And we set that equal to %. And if you run this, you can see it's now been normalized. Now, typically for such a normalized plot, it's useful to have labels. So again, we can add text auto equals true to add some labels. Let's do that in a new code section. And maybe we can press enter so we don't get too cluttered up. So text auto equals true with a capital T. And now we have some labels, but as you can see, there are a few too many decimal places. So in order to reduce the number of decimal places, what we can do is set the following. Instead of text auto equals true, we say text auto equals .1f. And that just means one level of precision or one decimal place. So now we have one decimal place on those percentages, and that looks okay. Let's do some practice. So open a new code section now. And for the second practice question, it's going to be very similar to this other one. So let me just grab this definition, and you're just going to convert that to a percent stack bar chart. So use the G2007 income dataset created above to build a percent stacked bar chart, showing the proportion maybe, or the percentage of high and low income countries per continent. So pause the video and try that out. And now I realize we haven't done this one, the grouped and clustered bar chart. So let's do that. I'm going to open a new text section and call it, let's call it clustered bar chart in this case. And all we're going to do is let's grab some of this existing code, maybe this one. And we can remove bar norm percentage since we're not normalizing it. We're just going to set bar mode equal to group. And that should give us our clustered histogram. So remember that the default behavior, if we set no bar mode, is to create them stacked. But now if we set bar mode equals group, then we create them as a clustered bar chart like that. So we're basically done looking at the different types of visualizations in this flow chart here. To wrap up, we're going to look at a couple more classes of data visualizations. We're going to look at time series plots, which let you look at how a specific variable changes over time. And then we're going to look at a plot with more than two variables. So far we've been looking at two variable plots, sometimes called bivariate plots. But then now we're going to look at multivariate plots. So let's start with time series data. So time series plots. Open a new code section. And what we're going to do to create a time series is we'll subset the Gapminder dataset to just a specific country. As you can see, for each country, you have multiple values for different years. So we're just going to subset to only Nigeria for now, because that's where I grew up. So let's grab the Nigeria population data, and we're going to type gapminder.query. We're going to set country equal to Nigeria, and then we extract just the year and the population columns, year and population columns. And let's print that so we can see the data set that we're about to plot. And to plot this, we start out with a bar chart, so px.bar. Here again, notice that the value I'm going to put on my y-axis is already in a column. So we're using bar chart, not the histogram. So px.bar Nigeria pop is my data set. My x-axis is going to be the year variable, and my y-axis is going to be the population variable. So now we have this time series showing the population of Nigeria over time. In addition to a bar chart, it's also common to plot a time series on line charts. So let me open up a new code section, and I'm just going to swap bar here with line. And that also gives you a line chart. And you can show the specific points that you have measurements for on this line chart with markers. So let's open a new code section. Let's clear this output. Open a new code section, and here we set markers equals true. And now we can see what that looks like. So it's easy to see the exact points that you have measurements for. So based on that, let's do a very simple practice. Let's do a very simple practice question. What I want you to do is use the Gapminder dataset to create a time series of the GDP per capita of Iraq. And after you've looked at that time series as a bit of a history lesson, I want you to answer the question, what happened to Iraq in the 1980s? In the 1980s, that might explain the shape of the graph. That might explain the shape of the graph. Now, the last thing we're going to do is look at some ways to visualize more than two variables at a time. That's multivariate visualization. So let's open a new text section and say plots with more than 2 variables. And the first type of plot we're going to consider is a bubble chart. And bubble charts are simply scatter plots where the size of the point is mapped to some variable. Let's see an example. I'm going to type px.scatter, and we're going to use the G2007 dataset that you have defined further above there. If you've lost that dataset, go grab it and redefine it. And we're going to put on our x-axis the GDP per capita. And then let's set y equal to life expectancy, y equals to life exp. And we run this, and that's just a basic scatter plot showing GDP per capita against life expectancy. But we can also add a size argument here, and that will map the size of the country to the population. So now you can see big countries. For example, this one here is probably India, and this other big one is probably China, and that other big one is probably the US. So now we have 3 variables on this plot. Let's add a 4th variable. We're going to color them by continent. So I'm going to set now color equals to the continent variable. And now you have 4 different variables here. Now there are ways to customize the labels on each of these points so that you can see the specific country that is, but I will leave that to you to do your own research. For now, I want you to do some practice on this. So you're going to use the tips dataset since we've used Gapminder in the example. So use the tips dataset to create a bubble chart showing the relationship between the tip amount, and the bill amount. And the size of the points should be mapped to the size of the party. So let me just print the tip so you can remember that there's this variable here, size, which indicates how many people were in the specific gathering for which they paid that amount. So this size here is what you're going to map to the size of your points. Okay, now the very last thing we're going to do is look at facet plots. So open a new text section and call it Facet Plots. Facet plots are the final way I'm going to show you to plot more than 2 variables on a single visualization. So let's start with a simple scatter plot with px.scatter. Why do I have caps lock on? px.scatter. And we're again using G2007. So that's Gapminder subsetted to the 2007 year. And we set x equals to GDP per capita and y equal to life expectancy. So just as a reminder, here's what that plot looks like. And now we're going to add a facet call argument. Facet call equals continent. So what this is going to do, well, let me run it so we can see, is you have this specific facet is just the countries in Asia, continent Asia. This one is countries in Europe. This one is countries in Africa, and so on and so forth. In order to make the countries a little bit more distinct, I'll grab our size and color arguments from here, and I'll keep those in this plot. So we keep in that information. And as you can see, the information is a little bit squished, so we can define the number of rows and columns. And let's do that. So I'm going to open up a new code section. Let's clear this output, open a new code section, and I'm going to add the argument of facet call wrap, and that defines the number of columns to have. And let's set columns to 2. And so now we have 2 columns. It's a bit easier to see each plot. Okay, so now here is a practice question for you. So I want you to use the tips dataset to create a percent stacked bar chart, okay, of the time column colored by sex. So let me show you tips one more time. So tips has this time column, and this time column has the values, I think, dinner or lunch. So time is going to be on your x-axis, and then you're going to color by sex or stack by sex. And then I want it to be faceted by the day column. Then when you do this, I want you to answer the following question: which day time, so maybe like Sunday dinner or Sunday lunch, which day time has the highest proportion of male customers? So that's a bit of a hard one, but I think you can do it. Pause the video and try it out. So congrats on getting through this long lesson. Let's go through our list of learning objectives. I think we'll start with this flowchart here. So by now, you know how to create scatter plots for numeric versus numeric data. You know how to create grouped histograms and grouped box plots, and also bar charts to plot numeric versus categorical data. And for categorical versus categorical data, you know how to create stacked bar charts or clustered bar charts or percent stacked bar charts. So that covers our first 3 learning objectives there. But in addition now, you've seen how to visualize time series data using bar charts and line charts. You've seen how to create bubble charts to display the relationships between 3 or more variables. And then you've also seen how to use faceting to compare distributions across subsets of data. So in this lesson, you've seen how to create a wide range of bivariate and multivariate graphs using Plotly Express. These techniques and functions that we have taught you will take you very far in the world of data viz. So happy plotting, and I will see you in the next video. Bye-bye.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.